Do you know how to derive these two formulas? In this video, I will show you how to derive the total resistance formula in both series and parallel circuit. Let's dive straight into it. Okay, for this series circuit, we will recall the properties or behavior of a series circuit. We know that in a series circuit, current is the same, which means I is the same throughout the network. So we can write that I, which is the total resistance, I, which is this current, is equal to what? I1 is equal to this current, I1 is equal to I2 and is equal to what? I3. And also we know that in a series circuit, voltage is what? Differs. The supply voltage differs in the circuit. The voltage that drops according to R1 is different from the voltage that drops according to R2, and the voltage that drops according to R2 is different from that which drops across what? To R3. So with that, I can write that V is equal to what? V1 plus V2 and plus V3. So I can call this equation what? 2. I can call this equation 1. So we will recall Ohm's law. This is what we are going to do. Since voltage differs in a series circuit, we will look for what? The value of the individual voltage and substitute them into what? Equation 2. We will look for the value of V, we will look for the value of V1, V2, and V3 and substitute the individual values into this word, equation 2. So now, but we know that from Ohm's law, V is equal to what? I arrow. Are you seeing? We have gotten the value of V from Ohm's law. And with respect to Ohm's law, we can what? Get the value of V1, V2, and V3. So with respect to Ohm's law, the value of voltage drop across to V1, the value of the voltage that will drop across to V1 will be what? I, which is I multiplied by what? R1. R1. And the voltage that will drop across to what? R2 will be what? V2, which is equal to I, which is I2, which is the same thing as I multiplied by what? R2. And the voltage that will drop across to what? R3 will be V3, which is equal to what? I3, which is the same thing as I multiplied by what? R3. We can call this equation what? 3. Okay, since we have gotten the value of the individual voltage drop across the individual resistor, we can now substitute this value now into equation what? 3. So now let me bring down, write the equation 3 down. V is equal to what? V1 plus V2 and plus V3. So at this point, we can substitute the value of the individual voltage. So for V, we have that V is equal to I arrow 1, which is I arrow. And for V1, we have that V1 equals to I arrow 1, which is I arrow 1, plus V2 is I arrow 2, and V3 is I arrow 3. So at this point, something is common, I is common. So we will factorize I from the word equation. So we have that I arrow is equal to what? I is common, so we will factorize I out. So we have arrow 1, arrow 2, and arrow 3, which is arrow 1 plus arrow 2 plus arrow 3. And since we want to make arrow the subject of the formula, because what we are looking for is the total resistance in a series circuit, we will make arrow the subject of the formula. And this very point, we can divide both sides by what? I. Divide here by I. Divide here by I. I will take away I and I will take away I. So I, which is the total resistance, is now equals to what? Arrow 1 plus arrow 2 plus arrow 3 plus any number of what? Any values of what resistors. So this was how the word, this formula came about. So we are done with the series circuit. So let us dive straight into what? This parallel circuit. So let me clean the board. The same thing we did to series, that is what we are going to do to parallel. We know that in a parallel circuit, the characteristic of the parallel circuit, we know that in a parallel circuit, voltage is the same, which means V, which is supply voltage, is equals to the voltage that just occurs to other one, which is V1, is equals to V2, equation 1. We also know that in a parallel circuit, current is the same. So current differs. So this supply current I will be equals to what? This plus this, which is I1 plus what? I2. You can call this equation 2. Since current differs, we will look for what? Our aim is to look for that what? Value of current that differs in this what? Parallel circuit. So what are we going to do? We will look for the value of I, the value of I1, the value of I2, and now substitute them into equation 2. But remember, for Ohm's law, we know that V is equals to what? I arrow. From Ohm's law, we can find the value of I. So by making I the subject of the word formula, so by making I the subject of the formula, we divide both sides by what? Arrow. So by dividing both sides by arrow, this will take away this. So therefore, I will now equals to what? V over what? Arrow. So that is for I. We are plotting I. And since we are plotting the value of I, we can now find I1 and I2 with respect to I. So for I1, let me use this other color. For I1, will be equals to what? V over what? Arrow 1. For I2, will be equals to what? V over what? Arrow 2. So now we can now substitute this word, these values into what? We can call this equation what? 3. We will now substitute this equation 3, which are this value of the individual words called into this equation 2. So by doing that, we will have that for I will be what? For I, we have that I is equals to what? V over what? Arrow. Equals to, for I1, we have that I1 equals to V over arrow 1, which is V over arrow 1. Plus, for I2 is V over what? Over arrow 2. So, we have input the word, this individual value of current into this equation 2. So we have this. So at this point, something is common. V is common, but this formula can be written as 1 into 1 over what? Arrow in bracket equals to what? V. Since V is common here, we will factorize V. We have that V will equals to 1 over arrow 1 plus 1 over what? Arrow 2. Are you seeing? Sorry, here is V. Here is V. So that V multiplied by 1 is the same thing as this part is the same thing as this. So now at this point, what we are looking for is the equivalent resistance, which is arrow T in the word parallel circuit. So at this point, this can take away this, or we can divide both sides by the coefficient of what? 1 over what? Arrow T, which is V. Any of them will work. So in a parallel circuit, our final answer now, which is the total resistance in a parallel network, is now equals to 1 over arrow, will now equals to what? 1 over arrow 1 plus 1 over what? Arrow 2 plus any number of what? Resistors. So this is now the formula, the total equivalent and the equivalent word resistance in a parallel circuit. So that was how the formula came about. If you have watched to this extent, do well to like this video and subscribe. so that whenever I upload video like this, you will be notified. I mean subscribe now so that you don't miss out. Bye.